Okay, AP Pre-Calc nerds, 8th period, last period of the day, ran out of time, didn't get through the last 4 questions of the prerequisite test review. So I'm going to go ahead and get those 4 knocked out right now. I am going to move a little bit quickly because you have the ability to pause. Remember, you can hit me up on Rooms, and I will answer all the way until stupid late, like 10:30 or something, okay? Alrighty, this says to find the domain of a rational function. So a lot like this one, domain just means what are the numbers that we're allowed to use for x. This is a fraction. There's a single rule about fractions. You can never divide by 0. So all we have to do is make sure that the bottom of the fraction does not equal 0. So we go, all right, 4x plus 8 had better not be 0. Subtract this 8 from both sides. Get you 4x had better not be equal to negative 8, and then divide by 4. X had better not be equal to the number negative 2. So the domain of f of x is all real numbers except the number x equals 2. That is the only problem for the domain of this graph. It exists at every single x value except for that one. Now, if you wanted to know what that looked like in interval notation, you don't need to do it for this question, but it would have looked like this. Negative infinity all the way up to the number, oh, I forgot my negative sign on my 2, all the way up to the number negative 2. There would have been a parenthesis there, then a union, and another parenthesis at the negative 2, and then go to the right. This literally includes every single number to the left of negative 2 and every single number to the right of negative 2, and it just hops over negative 2 with that little union symbol. This is how it would have looked on the test. I won't make you do that right now. Real question, though, is what happens if I combine these two rules? What if you have a radical on the bottom of a fraction? Like this question I'm making up right now. When this x plus 13 radical was not in the bottom of a fraction, we said, oh, whatever's inside of a square root bar can't be negative, so it could be greater than or equal to 0. So you want to think that x plus 13 is just greater than or equal to 0 again and get x by itself. But the problem is this square root itself cannot equal 0 anymore because now it's in the bottom of the fraction. So in this situation, both this rule and this rule take effect. And what you say is the x plus 13 has to be strictly positive. It has to be greater than 0. It can't be equal to 0 anymore because if x plus 13 is 0, I have 1 divided by 0, and that's not allowed. Subtract 13 from both sides, and you would get x is greater than negative 13. That's a bonus question for you. So I said 4 is actually 5. Okay. All right. Rational expression in lowest term, that means factor and simplify. Students will often want to cross off the z squared and the z, but you can't do that, and I can prove it to you with numbers. Check this out. 2 plus 3 divided by 2. I think everybody and their dog can see that this is the number 5 over 2. But if you tried to do this, you would get 3 over 1, which is not allowed. 3 over 1 is not 5 over 2. So you cannot do that. It's because of this plus or minus right here. The only time you're allowed to do any kind of canceling is when you have numbers that are multiplied or divided. So if they're multiplied and divided, so if you have things held together with multiplication dots, this is 6 over 3, which is 2. 3 divided by 3 is 1. You still get 2. This is allowed. This is a big fat no-no. Okay? Okay. So instead, what we need to do is factor this. We need to know the two numbers that multiply to 4 that add to negative 5. And those two numbers are negative 4 and negative 1. So again, multiplies to 4 and adds to negative 5. The two numbers that multiply to negative 20 and add to this positive 1 that sits in front of that z. The two numbers that multiply to negative 20 and add to 1 are negative 4 and positive 5. These are held together with multiplication, and so are these. So since everything on the top is held together with multiplication and everything on the bottom is held together with multiplication, I can do some canceling. This x minus 4 cancels this x minus 4, and I am left with x minus 1 over x plus 5. Oh, crap. Okay, hey, I wrote x instead of z. Don't kill me. Sorry. Just pretend those are all z's. Whatever. It's already here. Here's the thing. When it was factored like this, because of the stuff that I just told you on this page, the bottom of a fraction can never be 0. That means this x minus 4 can't be 0. So right here, I can see that x can't be the number positive 4, because if I plug in positive 4 here, I get a 0, and that's not allowed. And I can also see that x can't be negative 5, because again, if I plugged in negative 5, I'd get a 0, and that's not allowed. Then I canceled stuff, and I got to here. This one shows me that only one number is a problem for x. This one is showing me x can't be negative 5, but I can still see that. And if I couldn't see that, I never would have known that there's another problem with x. And that other problem is right there. So since this doesn't show me that problem, I have to mention that problem. Essentially, it works like this. If you cross an x off the bottom of a fraction, you just created a number that you have to mention that x is not allowed to be. It creates a domain restriction. Because if you don't say this graph and this graph are not perfectly identical, because this has two numbers that it doesn't exist at. That has one number it doesn't exist at. Now it has two, and that makes them perfectly identical. Number 29. We're going to factor this difference of two squares right here. But look at this 9 minus x and this x minus 9. Notice, please, that the order of subtraction is backwards. If ever you want to switch the order of subtraction, all you have to do is factor out a negative 1. X squared minus 25, this is a squared minus b squared. That's going to be x plus 5, x minus 5. Difference of two squares, once again. Here's my x plus 5 from right there. And I'm going to switch the order of this by dividing out, factoring out a negative 1. Like that. And now, because everything is held together with multiplication dots, there's multiplication there, and there's multiplication there, and there's multiplication there. Because everything is held together with multiplication dots, I can cancel anything from the top that matches something on the bottom. This x minus 9 matches this x minus 9. Uh-oh, I just crossed out an x. I'm going to have to mention that x cannot be the number positive 9. This x plus 5 cancels out this x plus 5. Uh-oh, I just crossed an x off the bottom of a fraction. I'm going to have to mention that x cannot be negative 5. It cleans up to, oh, there's nothing left on top. Well, there's always something there. It's a 1. And on bottom, all you have left is this x minus 5. And for fractions, it doesn't matter if you say the top is negative, the bottom is negative, or the whole thing is negative. So I'm going to take this negative sign and put it right there because I think that's pretty. Of course, this is only showing me x can't be positive 5. It's not showing me, like it used to, that x also can't be the number negative 5. And it also cannot be the number x equals 9. There you go. Now that and that are identical. And lastly, factoring everything we can. X squared minus 9 is the difference of two squares. It's an a squared minus b squared situation. So x plus 3, x minus 3. 8 over. The two numbers that multiply to 9 and add to negative 6 are negative 3, negative 3. Do yourself a favor. Don't let that say minus a fraction. Make it say plus a negative 1 over. And I just have an x plus 3 down there. And I'm going to go ahead and throw some parentheses on it. We cannot add fractions unless they have a common denominator. So your job is to go to any of the denominators, it doesn't matter, and then just ask yourself, what is it missing that something else has? And then put it there. Well, it is missing a second x minus 3. This one has two x minus 3s, and this one doesn't. So this one needs a second x minus 3. But if you multiply it to the bottom, you have to multiply it to the top. This is now the least common denominator. You can see then that this one is missing an x plus 3. I ran out of space, but I'm going to multiply it to the top and bottom. And be darned, this one has an x plus 3, but it's missing both x minus 3's. But just so you know, x minus 3 times x minus 3, that is this. So when I combine this to one fraction, instead of writing x minus 3 times x minus 3, I'm going to write what it equals. That right there. So one fraction. I've got x times x minus 3 plus 8 times x plus 3 minus 1 times what x minus 3 times x minus 3 equals. All of that is over our least common denominator, which was x plus 3 and a pair of x minus 3's. And instead of writing x minus 3 twice, I'm going to do it like that. Okay. Distribution here and here, here and here. And this negative 1 gets distributed to all three things. And that is why I told you to write it as a minus 1, so you wouldn't forget that you have to distribute a negative. I'm not going to write the denominator for a minute. X times x is x squared. X times negative 3 is negative 3x. 8 times x is 8x. 8 times 3 is 24. Distributing the negative 1 gets me a minus x squared plus 6x minus 9. Remember, that's all over this stuff, but I'm not writing that right now. I'm trying to be lazy. Combining like terms. But hey, look. These x squareds cancel. That's good news. That's less to write. Negative 3x and 8x makes 5x, and 5x plus 6x is 11x. And 24 minus 9 is 15. And here is my least common denominator. And that is complete. Okay, thank you, nerds. I hope that these last 3 days were beneficial, and I will see you tomorrow for our prerequisite test.